Hey guys, welcome back to another video and I hope you guys are doing extremely great. And in today's video, we are going to solve this question, LeetCode question number 53, maximum subarray. And as always, we will go through the brute force solution first. Okay. And then we will discuss its time and space complexity. And after that, we will try to optimize it. And after optimizing, again, we are going to discuss the time and space complexity. Okay. So for this particular equation, we are going to discuss two different approaches. The first one is going to be the brute force approach, and the second one is going to be the optimized approach. Okay. And we are going to discuss the time and space complexity of both of these approaches. So make sure you stick around till the end with your pen and paper, and let's get started. Okay. Now let's understand what the question is saying. So we are given an array of integer. Okay. And our task is to return the contiguous subarray that has the largest sum. Means we need to find the subarray that has the largest sum. Okay. And what subarray is? Subarray is the contiguous part of the array. What I mean by saying is, this is a subarray. Okay. This is also a subarray. This is also a subarray. Okay. This is also a subarray, but it should not be like first element we have taken from here and the next element we have taken from here. No, it should be contiguous. Okay. This is also a subarray, right? From here to here, all these elements are a part of subarray. So this is also a subarray, and you can see for this particular subarray, we have the maximum sum. So that is why we are returning 6. So because this is the only subarray that is having the maximum sum, so we are returning 6 here. So now we understood what subarray is and what we need to do in this question. We are given an array of integer and our task is to return the contiguous subarray that has the largest sum. Same in this example, if you look at these particular array elements, you will notice that this entire array elements are also a subarray and they are having the maximum sum of 23. So we are returning 23 here. Okay. So how we are going to do this question? Let's see. So let's first understand the brute force approach. Okay. In the brute force approach, what we can do, I'm gonna take the same example here. Okay, this one. So what we can do in the brute force approach, it is very simple. We don't need to think much. We need subarray. So what we are gonna do, we are going to find all possible subarrays. Okay, because in the question we are asked us to find subarrays, right, with the maximum sum. So we don't need to think much. We are going to generate all possible subarrays in this brute force approach. And how to generate all possible subarrays? This thing you need to remember, because this template that I'm gonna write, you are going to need it in many questions wherever you are trying to generate all possible subarrays in the brute force approach. So the same template you are going to use there as well. Okay, so make sure to understand it properly. So how we can generate all possible subarrays? I will start from here. Okay, for this array element, this is also a subarray, right? These two are also a subarray. This is also a subarray. This is also a subarray. This is also a subarray. So what we need to do, first loop we need for traversing all the array elements. Okay, and the next loop we need to generate all possible subarrays. So this is for j. J will start from I, because this is also a subarray, right? We cannot write j is equals to I plus 1. We cannot start the loop from here. No. So j equals to I, j less than nums dot length. We can go till the last. Okay, and j plus plus. So that is how we are going to generate all possible subarrays. Okay, and what we need to do, we need to find the maximum sum. So here we can take sum equals to 0, and we can also take a maximum in which we can store integer.min value just for the comparison part. So now you understood the idea what we are doing in the brute force approach. First, we are generating all possible subarrays. Okay, we have a sum and we have a max. In sum, we are going to store the sum of all those generated subarrays. Okay, and we are updating our max with the maximum sum as we are traversing and as we are generating the subarrays. So here what we can do, sum equals to 0, and here what we need to do, sum is equals to sum plus nums of j, right? Sum is equals to sum plus nums of j. So what we are doing, first we are finding out the sum of that generated subarray. Sum equals to sum plus nums of j. Okay, and then we are updating our max. Max is equals to math.max sum comma max. Okay, this way we are generating all possible subarrays and we are updating our max. And once both the loops are completed, finally we are going to return the max, because in this max we will be having our maximum sum subarray. Okay, so that's how we can solve this question using the brute force approach. The idea was very simple. You don't have to think much. In the question, it is being asked, we need to return the contiguous subarray that has the largest sum. So we need to generate subarray, right? So what we are doing in the brute force approach, without thinking much, we are generating all possible subarrays. Okay, and we are finding out their sum and updating our max like this. Okay, and once the loops are completed, finally we are returning max. okay, because this max is going to have the maximum sum subarray. Okay, and if I show you the code, that's how the code will look like. What we are doing here, first we have max equals to integer dot min value, and then we have sum equals to 0. Okay, and what we are doing, we have two loops here for generating all the possible subarrays, and while we are generating the sum, we are updating our max also. First we are finding out the sum of that subarray, and then we are updating our max, and once all the loops are completed, we are returning our max here. So you can see we have used two loops here, so the time complexity is big of n square. Okay, and we haven't used any extra space, so that's why the space complexity is constant. But this is not good, right? And interviewer also will not be happy, and he will ask us to optimize it. And the second thing is, this big of n square, this time complexity is not going to work for large test cases. It is definitely going to give us the TLE error, time limit exceeded error. Okay, so that's why we need to think of optimizing it. So how we are going to optimize it? The idea is very simple. I'm again gonna take the same example that we took in the brute force approach. Now just observe what I am doing. I will start from here, okay, and I am not gonna generate all possible subarrays. No, this time I am not gonna generate all possible subarrays. What I will do, instead of checking all the subarrays, we are going to build the solution as we go. Okay, instead of generating all the possible subarrays, what we are going to do, we are going to build the solution as we go. Okay, and for that we need two things. First we need sum, and then we need max. Okay, and the approach that I am telling you, this is Kadane's algorithm. So the story is, we are using Kadane's algorithm here. Okay, I'm gonna write it with a pen. So the story is, we are going to use the Kadane's algorithm here. Okay, and Kadane's algorithm, the concept of Kadane's algorithm is, instead of generating all possible subarrays, we are not going to generate all possible subarrays, but we are going to build the solution as we go. Okay, we will be building the solution as we go. As we are traversing the array, we will be building our solution. Okay, we will be building our solution of finding out the maximum sum. Okay, and for that we need a sum. This is our running sum. So as we are traversing, we will keep on adding the elements to it, and we will keep on updating it. Okay, and if at any point, because we can see this array has negative elements as well, so if at any point, if my sum becomes negative, then I need to think that there is no point in carrying this sum ahead, because whatever the maximum sum I'm gonna get, this negative is definitely going to reduce it. Okay, for example, if this sum is -2 and the maximum sum is 5, okay, and if I carry it ahead, so this is definitely going to reduce 2 from this 5, right? So this is definitely going to make it 3. So, and we need maximum, we don't need minimum, we need maximum. So that's why there is no need of carrying this negative number ahead. If the sum becomes negative, there is no need of carrying it ahead. Okay, the better idea is just reset it to 0. Just reset it to 0. A better start will be a good idea. Okay, we will also see this in action when we were doing the dry run of this. And while doing all these things, we will also be figuring out our max. Okay, and once the loop is completed, we will be having the maximum sum in this max variable that we can return at the end. Okay, now let's see the dry run of this particular example. Again, taking the same example. Okay, so what I said, again I am repeating. We will be using Kadane's algorithm. Kadane's algorithm concept is, instead of generating all possible subarrays, we will be building the solution as we go. This is the array. So as we will be traversing this array, we will be building our solution. And the idea is, the core concept is, if the sum becomes negative, there is no point in carrying this sum ahead, because this is definitely going to reduce my maximum sum. So there is no point in carrying this negative sum ahead. The better idea is just reset it to 0. Just make your sum equals to 0. Reset it to 0. A fresh start will be a better idea when your sum becomes negative. So that is why we are resetting it to 0. And while we are traversing, while we are going, we will also be updating our max every time with the sum. Okay, so how we are going to do that? Let's see. We will start from here, right? Let me erase all the things. We will start from here. Okay, this is my loop, I less than nums dot length. Okay, I'm gonna start from here. First I will figure out the sum plus equals to nums of I, right? And this is my max, and inside this max I'm making comparison with this max and sum, and whatever the maximum you find out from these two, just take it and update it in my max. Okay, and what I'm checking, if the sum at any point becomes negative, becomes less than 0, then there is no point in carrying that sum ahead. Just reset it to 0. This is the whole idea. Okay, and this is how we are going to traverse. So I will start from here. This is my sum and this is my max. Okay, inside my sum I have 0, inside my max I have nothing, just integer dot min value. Okay, so now I will start from here. minus 2. Sum plus equals to nums of I. Inside 0, I will be having minus 2. Max, math dot max, max comma sum. So inside this max, I'm gonna get minus 2, right? Now I will check if the sum is less than 0. Yes, it is. So is there any point in carrying this negative number ahead? Because we know this is definitely going to reduce my maximum sum. So that is why there is no point in carrying this number ahead. So what we will do, we will just reset it to 0. So now the sum is equals to 0. Okay, now I am here. I will check. I will again find out the sum. Sum plus equals to nums of I. Inside this sum, I have 0 plus nums of I. Nums of I equals to 1. So the sum will become 1, right? Max, math dot max is equals to max comma sum. So minus 2 and 1. Which one is greater? This one is greater. So I will update my max with 1, right? If the sum is less than 0, no, it is not. Currently, we have a positive number, so there is no need of resetting it again. Okay, we will move ahead. This time, I'm here, minus 3. What I'm going to do, first I'm going to find out the sum. Sum plus equals to nums of I means 1 plus minus 3, right? So it will give me minus 2, right? So inside my sum, I am having minus 2. And again, I'm going to make comparison between 1 and minus 2. So this one is greater, no need of updating max. Again, I'm going to check if my sum is less than 0. Yes, it is, because this is a negative. There is no need of taking this ahead. So what we are going to do, again, we are going to reset it to 0. So we have reset it to 0. Now we are here. Sum plus equals to nums of I, we will be getting 4, right? Again, we are checking sum and max. Which one is greater? This sum is greater. So we are going to update it. We are going to update our max with 4, right? We will check if the sum is less than 0. No, it's not. Okay, good. We will move ahead. Now we are here. Okay, now we are here, minus 1. Sum plus equals to nums of I. So 4 plus minus 1 will give me 3, right? So now inside my sum, I will be having 3. In my max, I have, we will make comparison. Math dot max, which one is greater? 4 is greater or 3 is greater? This 4 is greater, right? So no need of updating it. Then again, we are going to check if the sum is negative. No, it's not. We will move ahead. Now we are here. 3 plus 2 equals to 5, right? So I am going to update my sum with 5. Again, we will make comparison for finding out the max. 4 is greater or 5 is greater? This 5 is greater, right? So I'm going to update my max with 5. If the sum is less than 0, no, it's not. Very good. Let's move ahead. So here you noticed that whenever my sum is negative, I reset it to 0. But whenever my sum is positive, I'm taking that number ahead, right? I take that number ahead, I take that number ahead, I take this number ahead. But when my sum becomes negative, I reset it to 0, right? So this was the whole idea. Now I am here. 5 plus 1 equals to 6. 5 plus 1 equals to 6. I'm going to update my max. I'm going to update my sum with 6. And 5 and 6, which one is greater? The 6 is greater, so I'm going to update my max with 6. Okay. Is the sum negative? No, it's not. Okay, very good. Let's move ahead. Minus 5. 6 minus 5 equals to 1. Okay. Now in my sum, I am having 1. And inside max, I am having 6. So is there any need of updating it? No. So we will keep 6 inside my max as it is. Okay. Now I am here. 1 plus 4 equals to 5. 1 plus 4 equals to 5. But before that, we need to make comparison, and that condition is not going to true. So we will move ahead. Now I'm at 4. So 1 plus 4 equals to 5. I'm going to update my sum with 5. And inside my max, I'm having 6. Inside my sum, I'm having 5. Which one is greater? This one is greater. So no need of updating it. Okay. And whatever we are having in our max, we are going to return it. Because at the end, we are simply returning our max. So this was the whole idea. You just need to remember 3 lines. What is that? Instead of building all the possible pairs, we will be building the solution as we go. Okay, next thing is, if at any point my sum becomes negative, just reset it to 0. Okay, and while doing all these calculations, while doing all these operations, you need to find out the max as well. And when the loop finishes, you just need to return max. So these are the 3 things that you need to remember in Kadane's algorithm. Okay, this was the whole point. Okay, now I'm going to show you the code, how the code will look like. So this is how the optimized approach will look. Here we have a maximum sum, and here we have a sum. Okay, and what we are doing, we are traversing the array elements with just single pass. And while we are going, we are finding out the sum for every subarray, and we are comparing it with max sum. And whatever the maximum we have from these two, we are updating it with max sum. Okay, and if at any point my sum becomes negative, we are resetting it to 0. And once the loop is completed, finally we are returning maximum sum, because this is having our maximum sum subarray. So that's how we can solve this question using the optimized approach. And in the brute force approach, where the time complexity was big of n square, in this optimized approach, the time complexity is just big of n. Why? Because we are traversing the array element only once. and we haven't used any extra space, so the space complexity is going to be constant, but the time complexity is going to be big of n. So this is an optimized approach, and I hope you got the logic now. And this was Kadane's algorithm. Keep this thing in your mind, and the 3 points that I told you, you also need to remember those 3 points. Sure. So that's it for today. Make sure to like, share, and subscribe, and I will see you in the next video with another DSA concept.